In this example, we're going to solve this equation, but if you'd like to go ahead and try it first on your own, pause the video and do so, and then come on back and we'll work it together. Okay, so looking specifically at this equation here, it seems like we have a few parentheses here that we can kind of get rid of. And so let's do that by first using our distributive property and multiplying through. So on the left side here, we have this -6 that we can multiply by both of these terms. So -6 times 1 is -6. -6 times -2y will be a positive 12y. And that's that left side. So on the right side, let's go ahead and distribute the 4 through, and we'll have 12y minus 4. And then, of course, this -2 comes along for the ride. And the next thing you'll notice is we have some like terms here, this -4 and the -2. Let's go ahead and just kind of put those together. So I'll have 12y minus 6 over here on this right side. Well, both sides of this equation have a 12y, and quite frankly, both sides of the equation also have a -6. Let's start by subtracting 12y from both sides of the equation using our subtraction property of equality. So what we notice is that the y's cancel here, but the y's also cancel here. So what I'm left with is -6 equals -6. So what happens in a situation like this where you have an equation, but all the variables canceled out? Well, you'll be left with one of two cases. Either you'll have a true statement here, or you'll have a false statement. Well, does -6 equal -6? Well, it sure does. So that's a true statement. So what does that mean about the solution of this equation? Well, it doesn't matter what value we plug in for the variable. They end up canceling out anyway, and you're always left with a true statement. So you could say it's an infinite number of solutions, but more specifically, it's all real numbers. And once again, it's because you can plug anything in, and it will all work. So the solution for this equation is all real numbers.